Hello friends, in today's class we are going to solve previous year question from Semaphore. Welcome here and we are solving this question which says that consider the okay. Suppose we want to synchronize two concurrent process P and Q by using binary semaphore PS and T. The code of the process P and Q is given below. So this is the code of the process. Synchronization statement can be inserted at the point WXYZ, WXYZ. Which of the following statement lead to an output starting with output 0011. Okay, so we want this statement to execute in such a way that it should be printing the value 0011 in this way. For printing 0011, and if I am having P and Q as my semaphore variables, this statement should be allowed. Okay, this W should go into the print 0 and 0, and this Y should stuck. Okay, so now if I take the value here, PS at W, VS at X, and PT at Y, and VT. Okay, so we have to synchronize this variable in such a way that that did 0011. So S and T is the semaphore, P and Q is the process, sorry, S and T is the semaphore value. Okay, now, so what can be the answer here? If I execute here a P, let's say S, it should be successful. Okay, it should be successful. For that, I have to assign S value equal to 1. But if I say this statement, if I execute PT, it has to be unsuccessful, and for that I assign T value to 0. Now if it is PS, because I want this to be first, PS, it will be successful operation, and here in this case and it will make the semaphore value down, so again it cannot enter, and here PT will be unsuccessful. But the moment 00 will be printed by this, then I'll come here and I'll say V and T. Okay, and that will allow this one to go. It may be possible after VT again it will execute PS, but it will stuck over here. So here at Z I will again here write here VS. Okay, so again after that, if it is execute PT, it will not be able to perform it. Okay, so S should be initialized to 1 and T should be initialized to 0, and PS at W. Okay, PS at W, VT at PT. Okay, VT at X. Okay, PS at W and VT at X, fine. PT at Y and VS at Z, fine. S initialized to 1 and T initialized to 0. That seems correct. B seems correct. Okay, PS same option, VS at Z, S and T both initialized to 1, no. WV, this is something different. Answer is B for this case. Okay, answer will be B. That sequence will allow it to print 0011, and if it is proceed infinitely, that is okay. Okay, so this is one of the year question, that is 2004. Let's read out this question. Consider two processes P1 and P2 accessing the shared variable X and Y protected by two semaphores Sx and Sy. Okay, so X and Y, your shared variable, and Sx and Sy semaphore, binary semaphore. Both are initialized to 1. Okay, both are initialized to 1. Fine. P and V denote the usual semaphore operation, where P decrements the semaphore value, V increments the semaphore value. The pseudocode for P1 and P2 is as follows. Okay, now L1, L2, and then X equal to X plus 1, Y is equal to Y plus 1, V Sx, V Sy, signal, and signal. In order to avoid deadlock, the correct operation of L1, L2, L3, and L4 respectively. I don't want to avoid the deadlock. Okay, so what can be the deadlock? So here we have to px and py, we have to down it. Now if I do psx, let's see a situation, and if we'll do psy, and here if I write psy, and here I'll write psx, what will happen? So here I down it, it is successful, and this will also down it, it will be successful, and it will stuck here, it will lead to deadlock. Why? Because both variables are here. What they have done is they have successfully, able to clarify or clear the first statement L1 and L3, but when you come to this statement, then they will definitely going to stuck. Okay, so now there is a problem. Okay, px and py. Okay. Now here, what can be done here, that instead of both are this executing this sx operation, let them both of them execute px simultaneously on the same variable. So rather than executing psx, we also execute let's say sx over here. Sounds good? psx. Now if it is one, then either this will be successful or this will be successful. One of them will be successful, both will not be successful simultaneously. Correct? So now if this one is successful or this one is successful, one of them, then it will execute py over here, sy, psy. Right? So if I do this thing, let's see whether this causes the semaphore. So suppose this one is successful. So definitely this statement will be executed first and this will be successful. At the end of it, it will signal Vx, Sx and Sy, and that will allow this statement to go, and because Vx is already, the Vsy is already there, this statement will also be successful. Okay, so that may be the idea. Let's see the options. So that from options, where does it go? Okay, let's see. And this may be the option, maybe the correct option. Okay, sometime option can also help us in our understanding better. So PSY, here if I say PSY, because I have to, and L2 is your PSX, and PSX, and PSY. Okay, now here there is a issue, problem will come. If both are this is x and this is y, so if I interrupted here, and so both will stuck here and deadlock will occur. A is not the option, not possible. Okay, fine. What about second one? XY YX, XY YX, and that will also the same thing. XY YX will also lead into the deadlock situation. Correct? This is x, this is y, then y, and then x. X and y. What about this? No. PSX and PSX again. So now, no, this is not possible. PXSY and PSY. Now here they will be successfully able to execute first one. They will stuck here, deadlock will occur. So I'm left with only option D. D is the correct one, I guess. Okay, and let me write here. I guess that is my solution, I guess. Well, let's see. Here it is saying PSX SY. Okay, SX and SY. Here we will write same thing, PSX, and here I'll write PSY. Okay, now this will allow what both are checking X. So if it is successful, so this one is successful. Okay, so that will go here to this statement. Okay, and one of them will definitely going to stuck. It will access it, and then it will signal Vx. Then if it is, look at here, fine. Sy, if it is decremented, fine. Otherwise this Vxy will definitely execute and it will admit. Answer D is correct in this. Consider a non-negative counting semaphore S. The operation PS decrement S Vs increment S during 20 PS 20 P S and 12 V operation issued in some order. The largest initial value of S for which at least one PS operation will remain blocked is. Okay, the largest value of S for which at least one PS operation will remain blocked. Now, for blocking, if you want to say blocked, then what we need to see here that successful and unsuccessful. Unsuccessful when is it will be blocked. And let me take you before here means our slides here binary semaphore successful and unsuccessful definition. What if the value of the semaphore of decrementing is negative, then it is unsuccessful. Right? If it is negative, then otherwise it is successful. So here counting semaphore. If S value is less than equal to 0, then we are actually blocking it. Right? Less than 0. So it should be go to the negative one. Okay, negative one. So here when I look at this problem, if I take the value, suppose the at least one process, at least the largest value for which at least one process will remain in the block, remain blocked is. So here if I take the value, suppose 7. Okay, 7. So now if I do PS, randomly I have taken 20 PS, so that will make it to minus 13. And then I will do plus 12V, and that will make it to minus 1. Okay, and this minus 1 indicate here in this case indicate, oh, I thought that it's a random value. This minus 1 will indicate that there is at least one process is remain in the block state. Okay, so the largest value of S, it can be 7, for which at least one PS operation will remain in a 1 PS operation will remain in the block state. Okay, so answer here in this case is 7. Okay, so the next question is 2010 and it says that the following program consists of 3 concurrent processes and 3 binary semaphore. The semaphore initialized to S01, S10 and S20. How many time process P0 will print 0? Okay, that is the question. And here let me write here that S0 is equal to 1. S1 equal to 0 and S2 is equal to 0. Now, notice that this is a while true, no loop, single time execution. The first time when wait S0 will be executed, then S0 will become what? S0 will become 1 becomes 0 and it will print the first statement as 0. These two will execute concurrently running, though they execute S1 and S2, but they will stuck here because the values are 0. Now this will release the value S1, and that will make sure that this while loop breaks. And in that process, this will release the value S0. Okay. Now, after that, if it again releases the value S2, okay, after this, then this wait 2 that is stuck over here, that will also break the while loop and it will come back to the statement release S0. So both will release S0 simultaneously, not simultaneously, one after another. First this will release and then this will release. Now, if the order, if I say that release S1, then this wait loop breaks, and then it say release S0, and after that this execute release S2. Okay, and after that if I go back and again say wait S0, so because it has already released that value, S0 again becomes 1, and that wait S will again go through with this, and it will again print the value 0. Okay, then it will execute the statement release S1 again, and it has already released the value S2. Now if I come back here to the process which is stuck in wait 2, wait S2, which is already released, then again one more time this will release the value of S0. Again it will release S1, again release S2. No issue, no problem with this, because this will not again enter, and it will be again wait S will be successful, and the third value will be printed here. In this case is 30. So this sequence where first 0 will be printed, then it will release S1, then P1 executed completely. I am not going to P2 right now. Okay, P1 executed completely. Then again the second time 0 will be printed. Then I go to P3. Okay, and in that case third time will be also 0 will be printed, because 2 time release statements are there. Fine. So this is one sequence. So exactly 3? No. Why? Because suppose wait 0, first 0 is printed, and then it's a release S1. Okay, so now this is wait S1, and then release S0. That will make again S0 is equal to 1, something like signal. Now after this statement, suppose this S2 executed and wait S2 loop breaks. I am talking about interleaving. First release S1, then I go to P1. Okay, then I come back here and release S2. Then after that, going for this checking wait in a while loop, wait S2 and release S0 is executed. Okay, if it is executed, then both release S0, 2 times release S0 will have only one effect. And in that case, wait S0 will again execute and print only one time. Since I have executed both the release statement in one, let's say interleaving in the manner that it releases S0, then this comes and this, without going into the process P0. Okay, so one sequence can be lead into 3-0, but there is also one sequence where both release have a single effect. Okay, and that means it will print the value 2-0. Okay, so answer for this question will be at least twice. Okay, because for 3 you have to must have a sequence like release S0, then P1 will be completed, then again you come to P0, complete it, then it will say again release S2, and then you release one more time, then again wait S1 will be successful, and then so that sequence will go in this 3 time printing. Okay, so something like this, you execute P0 up to release 1. Even if you release S2, if you execute P0 complete, then you execute P1, then again you execute P0. Okay, and then again you execute one time P2, and then again execute P0. This sequence will print you 3 times. But if I give you a sequence P0, then you execute P0 complete, then execute P1, then execute P2, and then again execute P0. This sequence will give you only 2-0 printed. Okay, so answer for this question is A, at least twice. This is another question from 2015, and it says that consider two functions P1 and P2 and shared variable B. So B is the shared variable. Initially having 2 execute concurrently. So B value is 2 and 2 processes are executing concurrently. The number of distinct value B can possibly take after the execution is. Okay, so how many values it can take possibly after the execution. Now because of this interleaving, there are many different sequences are possible. Okay, many different sequences are possible, and there can be many different ways it can interleave. Now one, if I say this statement as 1, this as 2, this as 3, and this is 4. Okay, so there are 4 statements are there, and they can interleave in different way. How many ways? You will say factorial 4 ways, right? But there is an ordering. Ordering means what? That after 1 2 will come, and after 3 4 will come. So this is a fixed entity, that 1 and 2 will come in this order, 3 and 4 will come in this order, and that's why factorial 4 is the complete interleaving of the statement without ordering. For 2, this will become divided by 2, and that will make 24 divided by 4, and there is only 6 orderings are possible. Okay, so what is this 6 ordering? 1 2 3 4 interleaving. Then I can say 1 3 2 4 interleaving, 1 3 4 2 interleaving. 3, 4, 1, 2 interleaving, 3, 1, 4, 2 interleaving, 3, 1, 2, 4 interleaving. So this is the 6 different conditions are possible. Okay. Now, so 1, 2, 3, 4. What will be the final value of B? What will be the to B? One statement will make that B is equal to B. C is equal to what? 1. Let me write the value. C is 1. 2 minus 1, and B will become 2 multiplied by 1, and B will become 2. C will make it D is equal to 2 into 2, 4, and B will make it D minus 1, to 4 minus 1, that is equal to 3. So this is the first value. For 1 I have already calculated C is 1. For 3 I have already calculated, for D I have already calculated value is 4. For 2 is 2 minus B will become B is equal to 2, and for D B is equal to D minus 1, D is 4, so B will become here in this case is 3, that is also 3, not a distinct value. For this one, 1, 3, so 1 will make it what? 1 will make it, okay, let me write it separate here. So 2 I have done, 1, 3, 2, 4. So 1 will make it C is equal to 1. 3 will make it D is equal to what? B is not modified, 4. 2 will make it what? D is equal to 2 multiplied by C. So B will become 2. And finally D. I think this is the statement I have done, I guess. Okay, fine. So this is the same statement, and C is equal to 3. So 3 is the distinct value. Let me write it the next one here. 1, 3, 4, 2. So 1 will make C is equal to 1 will make C is equal to 1. 3 will make D is equal to 4. 4 will make B is equal to 3, and this will make C multiplied by 2, B will become 2. So that is the distinct value. For this 3 I have done 3, 4, 1, 2. 3 will make it what? D is equal to 4. 4 will make B is equal to 3. 1 will make C is equal to 2, 3 minus 1 now, okay, modified value 2, and B will become in this case is 4. Okay, so how many 4 I have done? 3, 1, 4, 2. 3 will make D is equal to 4. 1 will make C is equal to B minus 1, which is 1. 4 will make B is equal to 3, and 2 will make B is equal to 2 multiplied by C, and that is equal to 2. Final value. We have already done this, huh? Okay, so how many I have done? 1, 2, 3, 4, 5. Last one. 3, 1, 2, 4. 3 will make D is equal to 4. 1 will make C is equal to 1. 2 will make B is equal to 2. And 4 will make D is equal to B is equal to 3. So 3, 2, and 4 distinct value. No? So there is a one distinct value is 3, another value is 4, another I'm getting is 2. So 3, 2, and 4. 2 and 4, and that is equal to, after the execution, is 3. Answer for this question is 3. Okay, so this is the next problem. This problem we'll do after we'll understand somewhat classical problem of synchronization, producer and consumer problem. Now, concurrent execution P1, P2, and P3 shown below, and shared variable D is there. Initialized to 100. So D is equal to 100. The processes are executed in uniprocessor system in a time shared operating system. The minimum and maximum value of possible value of D after the 3 processes have completed execution is X and Y. The value is Y minus X. So maximum value will be possible in which case maximum value will be possible. Okay, so maximum value will be possible if I do this updation is lost. Maximum value. And concurrently it is possible. Suppose all the process D read D is equal to 100, this also read D is equal to 100, and this D also read D is equal to 100. Then this is the first one when D is equal to D minus 50 and D is updated to 50, suppose completed this process. Now this process comes here and then it will read the value. Okay, one sequence change, fine, wait. Okay, now suppose now not the three process, two processes. Suppose this read the value D100 or this value you can also take D100. Now D is equal to D minus 50 is done and D is updated to the value 50. After that, suppose there is an interrupt and process switches and it execute D is equal to D plus 20 and D becomes 120. So finally D is updated to 120. After that P3 starts, okay, and update the D value to 120, read the D value. So what it will read? 120 and update it to what? 130. So maximum value is possible in this case is 130. Minimum value, what we can do here in this case is a one sequence D100, D100, D100. This will update the value D to let's say 120, which is updated by this one and this will make 110. And finally this comes into the picture and it do minus 50 and D becomes 50. So 50 is the least value. Okay, minimum value that it can update here. Interleaving is there. Minimum value is 130 minus 50 is equal to 80. Y minus X can take the value 80. Okay, so these are the few problems related with your synchronization, where the main thing you have to focus on is the interrupt can occur anywhere and process can switch and start executing the next one at any time. Okay, so that's all for this discussion. Thank you.